In this video, we will be discussing the problem bundling from the Google Kickstart 2020 Round A contest. You can find the problem link in the description below. We are given n strings and we need to group these n strings in such a way that every group contains k strings exactly. So there will be n by k groups and it is given that n is a multiple of k. So there are n by k groups and each group has k number of strings. In this example, n is equal to 6 and k is equal to 3. And so we group these 6 strings into two different groups, where the first group are these first 3 strings and the second group are these last 3 strings. A score of a group is defined as the largest common prefix of all the strings in that group. So the largest prefix, which is common to all the strings in this first group, is of length 2. RA, RA, RA. Similarly, the score of the second group will be 4. Fire, fire and fire. Since fire is the largest prefix, which is common in all these strings. So the score for first group is 2 and the score of second group is 4. And the sum of scores is 6. We need to find out the maximum possible sum of scores in all possible groupings of these strings. So how do we solve this problem? We solve this by using a data structure known as Trie. If you are new to this data structure, go check out my video for Trie and then continue with this problem. We are using tries because our entire problem revolves around the prefixes of these strings, and we need to know that for a given prefix, how many words are there that have that particular prefix. In every node of a trie, we will have two information which we will be storing. First one being the variable called count. This will count the number of strings which end at this node, and the second variable we will be having will be prefixes. This will store the number of words which has the prefix which is denoted by that node in the trie. Let's consider a different example and see how we can use a trie to solve this problem. So here we see a trie which we have already built using a set of strings. Every node in this trie has two information, the prefixes and the count. So say for this node representing the string AC, we have 12 strings which has the prefix AC and 4 strings which end at this node. So there are 4 strings which are exactly A and C. So first we build this trie using the set of strings we got as input. After building this trie, we need to now start grouping the strings, and the groups must be in such a way that the common prefixes between the strings must be maximum. Now in a trie, as you go deeper, the prefix also becomes bigger. So say the value of k for this problem given is 3. That means every group must have 3 strings in it. And let's say I'm considering this node. There are 12 strings which has prefixes denoted by this node, that is AC. So 12 strings has its prefix AC. Now we traverse the entire trie using recursion and say we now end up at this node C. Now let's calculate the number of groups which will be formed such that the groups will have the largest common prefix which is denoted by this node. So whatever the groups that we form at this node will have the largest common prefix as AC. Now we know that there are 4 strings which are AC. So obviously I will consider these 4 strings for grouping. So I will have a variable called here which will store the number of strings that can be considered for grouping for this current node. So first here will be value 4 because there are 4 strings which are equal to this prefix AC. All these 4 strings are exactly equal, and so I can have them in the same group. Now what about these strings which are not exactly equal to AC but has AC as its prefix? So those strings will have AC and some characters followed by it. Now we need to find such strings which when grouped together will still have AC as its largest common prefix. So the strings which has AC as its prefix but not AC itself will be represented by the child nodes. So we will look at the prefix values for these child nodes 3, 4 and 1. This 3 indicates that there are 3 strings which has prefix ACB. Now if I group these 3 strings, how many strings will be left? There will be 3 mod 3 strings, or precisely 3 mod k, since every group can have only k strings. So there will be no strings left over here. For this node, there will be 4 mod 3, which is 1 string left. And over here, there will be 1 mod 3, again 1 string left for grouping. So other than this one string, all other strings will be grouped by the child nodes. So this single string can be used for grouping in this parent node. So the here value will be 4 plus the residues in the child nodes. So the residue in the first child node is 0. The residue in the second child node is 1. And the residue of the third child node is 1. And hence this here value will be 6. Meaning there are 6 strings which can be used for grouping, and their largest common prefix will be AC. To give you a better intuition on this residues, let's consider this node E. So there are 4 words which has ACE as its prefixes. Now if we group these 4 words, then any group will have the largest common prefix as at least ACE, because all of these 4 words have ACE in common. Here this node E doesn't have further child nodes, so all 4 strings are equal. But say even if it had child nodes, if I group all these 4 words, then these groups will have a score of at least 3, which is ACE. Now after grouping these 4 strings, there will be one string which cannot be grouped. That is, this one string cannot be put into the groups which is already formed by the other 3 strings. So this one string which has A, C, E and say maybe something after it cannot be put in a group where all these strings again have ACE. So this can be grouped in a group where we can consider this prefix AC. So that is why we add this one to this parent. So we're saying, okay, we cannot use ACE, so we will use AC itself. So now we add this one remaining string to this value here and consider it for grouping with the words which will have maximum common prefix as AC. After finding the value of here, I will find the value of scores of the groups formed at this node. Here value is 6, so there are 6 strings and I will be grouping them as sets of 3. So 6 by 3, which will be 2. So I will be having 2 groups now, and the depth of this node is 2. So the prefix length is 2. So 2 into 2 is 4. So the sum of scores will be 4. And I will be adding this 4 to the scores values provided by the child nodes. And that sum I will be returning it to the parent. So now let's quickly run through this algorithm on this entire trie for a clear understanding how this works. So we will start traversing this trie. So we will go to the leaf node, and here we group all these strings, calculate the answer for this leaf node. How many number of groups can I form here? I can form 3 by 3, which is one group, and the depth over here is 3. So the answer for this node will be 3, meaning the sum of scores of the groups formed at this node will be 3. Then for the next child node, it will be 4 by 3. We take the floor of it, so 4 by 3 will be 1, and the depth is again 3, so it will be 3. And for this node, this child node, the number of groups which can form is floor of 1 by 3, which is 0. So no groups can be formed here. So 0 will be returned from this child node. Now we come to this parent node C. So at this parent node, we will have here value as 4 plus the residue at the first child is what? It is 3 mod 3, which is 0. The residue at the second child node will be 4 mod 3, and the third child will be 1 mod 3, which is 1. So we get 6. 6 by 3 is 2. So we have 2 groups, and the depth is 2. So the total score will be 4, and we will be adding this score with the scores of the childs. So 3 plus 3 plus 0 is 6. So the answer for this node will be 10, which will be returned to this parent node. Now we will come to this child node, and here the answer will be 0, since no groups can be formed. 2 by 3 is 0. And for this parent node A, we again calculate the here value, which will be equal to 0 plus the residue as first child node is 12 mod 3, which is 0, and the residue at the second child node is 2 mod 3, which is 2. With value of 2, I cannot form a group since 2 by 3 is 0, and so the number of groups will be formed 0, and the sum of the child values will be 10. So the value at this node will be 10. Now we will move on to the second branch, and here once we reach this child node, the answer will be 3 by 3, which is 1 group having depth 3. So here it will be 3, and over here the here value will be 4 plus residue at child, which is 0, and using 4 strings I can form 1 group, and the depth is 2. So 2 plus the value at child node, which is 3. So we have answer 5, which will be returned over here, and over here the value of here will be 3 plus the residue at child node, which is 1. So we can form 1 group because 4 by 3 is 1, and the depth is 1. So the value at this node will be 1 plus the child node's value is 5. So 1 plus 5 is equal to 6. And obviously the root node, the answer will be 10 plus 6, which is 16. So the answer for this will be 16. So this is how you solve this question. If you've understood, then please do not forget to hit the like button. And if this is your first time here, then consider subscribing to Fluent Algorithms.